In the previous lesson, we learned how to find the mean and variance of a continuous random variable. So let's assume that the graph of the function is like this from A to B. And y equals f of x is a probability density function, meaning that the area under the graph is 1 and the function is always positive in the given domain. Now, how do I find the mode? Remember that the mode is most likely value. So most likely value, it's a value with the biggest probability. The value with the biggest probability is a maximum of the function. So that's your mode. Mode is a maximum value of the function. How do I find it? I find it where the derivative is 0. So that's how I look for the function. However, if the graph is known, I can see it from the graph. But generally, that's the rule. How do I find the median? The median, remember, was a value in the middle when the data was arranged ascending. So if you had discrete data, 1, 2, 3, 4, 5, 6, 7 data points, the value in the middle was the value on the 4th position. This means that you have 50% of the data on the left and 50% of the data on the right. So if I'm looking at continuous random variable, you are looking for a point here somewhere, I don't know exactly where, such that here you have 50% of the data and here you have 50% of the data. So the median, let me call it M, will be the point, so the median is M, such that integral from A to M f of x dx is 50% or 0.5. And from this equation, you are going to find M. So again, integral from A to M f of x dx, so this area needs to be 0.5 or 50%. Let's take an example on the next page. Please pause the movie and read the question. We are going to add question C, find the median. Right, so let's start. Question A. Find the value of k such that is a probability density function. So we know it is when integral from 0 to 7 kx 10 minus x dx is 1. Therefore, I'm going to open the brackets, 10 kx minus kx squared dx from 0 to 7 is 1. Therefore, 5kx squared minus k x cubed over 3 from 0 to 7 is 1. So 5k times 49 minus 7 cubed over 3 times k is 1. Therefore, if I solve this equation, so k equals 3 over 392. Question B asks to find the mode. We have two ways to do it. Either, so my function f of x will be 3 over 392x times 10 minus x. I'm going to start with the first method, which takes exactly the definition. Mode is a maximum value, so it is when the derivative is 0. Therefore, 3 over 392. If I open the brackets, x squared, it's 10x minus x squared. So if I differentiate, I get 3 over 392 brackets 10 minus 2x needs to be 0. So 10 minus 2x needs to be 0, so x needs to be 5. So the mode is at x equals 5. I could have done differently by observing that f of x is a quadratic function with the roots x equals 0, x equals 5. Therefore, the graph looks like this. 0, sorry, and x equals 10 is the second root. Therefore, the maximum value is the vertex of the function, and that is at x equals 5. Look at the median. For the median, I can do the same two methods. If I know the graph and I know that the parabola is symmetric, here I have 50% of the data, here I have 50% of the data. So the median is the same as the mode and is 5. It's not always the same. Assuming I don't know this method, I will need to solve the equation integral from 0 to m. I'm looking for this m, and assuming I don't know where it is, such that integral from 0 to m, 3 over 392 x times 10 minus x dx needs to be 0.5. So I need 50% of the data from the first margin to m. Therefore, I take 3 over 392 in front, integral from 0 to m, 10x minus x squared dx needs to be 0.5. So 3 over 392, 5x squared minus x cubed over 3 from 0 to m needs to be 0.5 or 1 over 2. Therefore, 5m squared minus m cubed over 3 needs to be 392 over 6. Now this was, see, I made up the last question. This was a not very successful question because you ended up with an equation that we don't know how to solve. We don't know how to solve cubics. But generally in such a question, you'll end up with an equation that you know how to solve, and therefore you can find m. I can check that m equals 5 is a solution, but you'll never get a question where you'll end up with this equation that you don't know how to solve. So 5 times 5 squared minus 5 cubed over 3 needs to be 392 over 6. And we can check this. Okay, so I put this in my calculator and I saw that actually this is not the case. So I have a mistake, so that's incorrect. So I look back to see why 5 is not a solution, because it looks like it needs to be a solution. And then I noticed that actually it doesn't have to, because I ignore that basically x is just between 0 and 7. So if you look at my graph, that's not the entire graph. I mean, it's too much. So I need to stop at x equals 7. So my graph stops here. Let me see if I can delete it. Right? So basically, this is my function up to 7, not up to 10. I can imagine that the root will be at 10, but actually my function stops there. So when I look at 50% and 50%, yeah, remember x equals 5 was from the mean. I will delete it. And now I'm looking at the median. The median is the point where I have 50% of the data on one side. So see somewhere here, I have 50% of the data on one side and 50% of the data on the other side. And this is my median that divides the area into 50%, 50%. Therefore, it's not necessary that my median, and it's not going to be 5. So I was looking for 5 wrongly. It's just another number. Going back, I don't know how to solve this equation, maybe just by trial and improvement, so it's outside the syllabus. whenever you are going to be given a question, you are going to end it up here with an equation that you know how to solve. However, this was a good question because it made us think and spot some common errors that might appear. As a conclusion, to find the mode, you have two ways. Either you know the graph, you look at the graph and you know where is it going to be, because you know it's a parabola, or sometimes it might not exist a mode. So you look at the graph, or the second method is finding where the derivative is zero, because you need the maximum point and showing that it is zero, it is a maximum. To find the median, you have also two methods. Either you can look at the graph and see if the graph is symmetric, especially where is the midpoint, or if not, solving an equation of this type. So you look for the point M, so that the area is split it into 50% and 50%.